session is designed to be interactive. The title is listed here, Is Systems Engineering Well Equipped for the Fourth Industrial Revolution? We have six distinguished panelists. I'm the moderator. And they will first present themselves, and they will have a few minutes to do that. We basically plan to have this in 3 rounds. The first round is to ask each panelist to give an overview of his domain background, expertise, and practice. So we have some context. Then to address the question of whether systems engineering is ready for the fourth industrial revolution. I assume everybody here knows about the first industrial revolution. Yes, the second, the third, the fourth. The fourth, who knows about the fourth? Okay. And in that context, what must be changed? This is what each panelist will address. We're missing one panelist, right? Oh, you're there. Okay, I didn't see you. Thank you. Yes, that's the person I was looking for, right? And in that context, what must be changed in systems engineering in this new era? We heard already 2 talks that describe that. So this is the first round. The second round, we're going to list some dilemmas, and this will be sort of open season. In other words, whoever wants to address these dilemmas will be invited to do so. And the third round is where the public sitting here, the participants in this conference are welcome to join in. So this is the plan, and we have a deadline of 12:15, which is when we have lunch. Is it lunch? No. Okay. There's something else after that. Oh my God. Okay. Okay. So I'm Ron Kennett. I'm a statistician. I'm an applied statistician. I've worked on topics like information quality, a wide perspective of what data science is about. I was a university professor. I was employed at Bell Laboratories, and I was the director of statistical methods for Tadiran Telecommunication here in Israel in the 80s. And in order to deal with the fourth industrial revolution, which is what, now when you hear a boom here, people wonder where it's coming from. I don't Okay. We have something that involves sensors, involves flexible manufacturing, involves IoTs, and involves analytics. And in that context, there is a role for a system perspective. And in the talk that Bob Schwartz, who is one of the panelists, will give this afternoon, he will present a book that we have edited that deals with this aspect of analytics in the context of system engineering and the fourth industrial revolution. We is Bob, Victor, and myself. And so if you want to hear more about it, it will come in the afternoon. And what system engineering is potentially going to do in this context is to provide some integration of data science disciplines. We heard the officer who talked about how it's a transdisciplinary environment. So you have different disciplines involved. So someone must orchestrate this potential chaos, and this would require methods. And the talk we had this morning is definitely along these lines. And the other thing that this really should consider, this is my view, my bias, is analytic skills, which from the work we do with industry is something that could be, should be improved. The vendors offer systems and sort of make a promise that these systems will make miracles, but you don't have, if you don't have the people with the analytic skills to integrate these systems, to make use of these systems, this promise is not going to be fulfilled. So these are my 2 minutes, 3 minutes on what we're going to talk about. And this is a book that was edited, came out last year, which is Analytics in System and Software Testing. And this is a book that will come out in May called The Real Work of Data Science. And if you look at Amazon, you can find them.
Good noon. Thank you for coming here. My domain expertise and practice is project management and system engineering. In the past, I worked on quality management, reliability, safety engineering, practicing research. All my years of working, I was practicing and also research in the Technion, also teaching in the Technion. And the question if whether if we are ready, or the system engineering discipline is ready for the fourth industrial engineering, I decided to do it by the in and out format or pattern. Now we are in a pattern time. I like this pattern, that something that has to go in, but something has to go out in order that you have a place to this. And I try to show you. You see, is a roll up here, all the things that has to be go out and those that has to be go in, and I'll only mention some of them. I was educated as waterfall process engineer. Everything has to go linearly, one after another, and between the stages there is something. There is a stage keeper, there is a design review or something. Something happens there. There is a gate there. What is happening now in the new era? Nothing like that is I think, effective anymore. We are more in the iterative. We are more in the agile format of working in the engineering, in the management, in the project management, and the system engineering. So everything has to be iterative and agile. We have also to put more system thinking. I, as a system engineer, I think that I've used some of the thinking, system thinking methods, but it was not applied as company. It's not applied as a project-wide. It was applied by some of the people that thought that it helps them to do the decisions. So we claim that almost everything that we have been practicing in system engineering in the last 20 years, we have now to replace by something that is more advanced, more adaptive to the new era of the smart technology. And for example, we have here preventing maintenance policy. I was working on preventive maintenance for years in our project. I suggested the policy, I suggested all the tools to be prevented, and I also train the people to do the preventing maintenance. Today, maintenance policy like predictive or condition-based maintenance or prognosis health monitoring is something that we can do in better way for ourselves and also for the system, for the customer, and also so to those that are applying the system. So I think that what we have to think that everything that we have done up to now in system engineering, and also I'm happy that Gary is here, the president of INCOSE. We have also talked in INCOSE meetings that we have to change almost everything that we have done in system engineering, from thinking through processes to think through systems, from thinking by documents to think by models. It was mentioned also by Ed in his talk this morning. We have to think through models, and the models is only truth that describe the system or the situation itself. And also what we have to use, and it was the other talk this morning about data. I feel that system engineer or system engineers don't use enough data for their decision making. So what we can do is using the data revolution or the big data revolution, that system engineer will be data driven, evidence based, what we call sometimes, and so, and will not be document based engineering. And some of the people blame us, system engineers, you bring us too many documents, so we have to bring more data for this one. And in this notion, I will only summarize the model-based system engineering that mentioned also this morning. I believe that this is a very powerful tool for us, powerful approach, powerful concept, as said Ed, that we need model-based system engineering and as our way of doing the work and our way of our professional life. And for that reason, we ask Matthew House to give the seminar tomorrow, how to implement model-based system engineering and not only talking about it. Thank you.
To write notes when you said we should introduce ourselves, and I thought I should know that by heart, who I am and what I am. So Bokar Tov, Toda Rabbah for having me speak this morning. That's the extent of my Hebrew. I've had a long professional history of teaching and practicing systems engineering, and started out in the aircraft industry. I worked for Pratt & Whitney Aircraft. Then I went to the computer industry, and I worked at actually a couple of computer companies, and I finished up in the defense industry. But all the time I was doing that, I was teaching also on an adjunct basis, because my true passion is in teaching systems engineering to engineers. And so I'm now on the faculty at Worcester Polytechnic Institute, and I run the systems engineering program there. And I'm trying to change things because I feel that the answer to the question is absolutely not. I will explain some of the details of why I say absolutely not as we go along. But I think things are moving too fast. I was trying to think about an analogy that I could make this morning to talk about where I think systems engineering is going. And the analogy I thought is do you know how if you go out to buy something for yourself, a consumer electronics product, a camera, a telephone, a television, whatever, the moment you buy it, it's obsolete. And that's kind of what's happening, I think, with systems engineering is things are moving so fast and changing so fast that all of the things we used to do with systems engineering are just inadequate. They don't respond quickly enough. And so I feel like there's a lot of change has to be made. I have some ideas about that. I think I can explain that later. And that's it for now. Stay tuned.
Is system engineering discipline ready for the fourth industrial revolution? I think it's struggling to catch up with the 20th century. You know, we had this thing called Y2K 19 years ago, right? And I was on the NASA committee of how NASA was going to react to the Y2K problem. And one of the members of the committee was a Catholic priest from a very small order that's existed for 11 or 1,200 years. And he said, in my community, we're still working on the Y1K problem. Right? So I think that model-based system engineering is in general lagging the economy and the fourth generation, the industrial economy, and the fourth generation appearance. By the way, the fourth generation stuff is really the marketing department of Siemens that sort of cooked up this, this concept, but it must be real because we're all talking about it, right? So it was a case where a marketing department pushed a button. So what's the solution? We just wait 20 years, right? Because the first digital natives are arriving at universities this year. A digital native is somebody who's had one of these since as long as they could remember, right? So they always had access to all the information in the world at all times, in all places, wherever they needed it. And they're a different kind of learner. So the first accommodation we have to figure out is how we accommodate digital learners in the teaching and learning of system engineering, right? And we've just made the transformation in the class I teach this year with, at MIT with Ollie DeVeck on advanced space system engineering, of going from waterfall to agile and from document to analytical. And we can do that because the kids in the room are digital learners, are digital natives. Right? And I'm not a digital native, I'm a digital immigrant. Right? I've moved to the digital society. And in industry we have digital immigrants and what one of my colleagues called illegal digital immigrants. Those are people who don't even try to become digital. Right? But the digital learners, I call them the digital immigrants, the students who are digital natives, learn in a fundamentally different way. And they expect all the information that has ever been made at their fingertips. And I'll tell you a story, and then I'll get off. I'm working, listen to this sentence closely. I'm working with a high school student on a new conceptual design for an aircraft. Right? I'll say that again. I'm working with a high school student on a new conceptual design for an aircraft. So here's a 17-year-old who got an appointment at MIT and is working with me on a new type of buoyant airplane. Okay? So I'm talking to him the other day because he's built robot airplanes all his life. You know, he knows how to write the code for everything. And I said to him the other day, we were having a problem with a dynamic stability issue in the tail. The tail was basically fluttering. And I said, we're going to have to do some analysis on this, Austin. Can you handle that? And he said, I'll find some code. See, this is the next step. Not only do they believe that all the data and information that's ever been is available, but they believe all the processes are also available. Not, you know, my graduate students who are only 5 years too old to be a digital native would say, I'll write some code. But this 17-year-old said, I'll find some code. Right? So the answer I gave was 20 years, and the question is, how long do we have to wait before the digital natives take over system engineering? Because we can't convert. We're not agile enough. We're too old. And I would say that everyone in the room is too old, even the 25-year-olds in the room. Right? You can't compete with the 15-year-olds. They're just going to take over. So what we got to do is figure out how to get through the next 20 years until the digital natives take over, and then we can all retire.
Shalom. My name is Matthew Hawes. I work for PTC, and universally everybody says, who are they? Because wherever I'm talking, it's not the area for them. This is getting more exciting. Okay. And PTC started out doing CAD tools. They were the first tool to actually do 3D CAD. Anyone know 3D CAD? We also do wind chill, which is for PLM, product lifecycle management. So we started sort of towards the end of let's build a system, gradually working our way backwards, and I do the MBSE part of it, which is how do you actually figure out what you need to build in CAD? And then also the requirements engineering, and into smart factories, Internet of Things and telemetry systems, predictive analytics, and also service lifecycle management and service parts management, trying to do smart availability for parts, predicting when they're going to fail. Because in the past, the way you used to do this is you'd say, well, I'll just buy twice as many parts as I need. And then, however, if you're moving around, that starts to get awkward, especially if it's a military type system. So all these things are, as several of the people have said today, data-driven and making use of how do we analyze this data so it's available on time right away wherever you need it. And that's what PTC does. And kind of my entire career, I've sort of worked my way through the life cycle, because I started out working for Houston Lighting and Power, building transmission lines, which are the really big ones, and then worked for a couple years in distribution, where you're actually bringing power to people's houses. So you're talking to people, learned a lot. This was in Houston. And then transmission planning, which is how do you predict what power needs a city is going to need in 20 years? How does it expand over time? And the fact that if you change a small thing here, it can have a dramatic impact on the entire system. Then I worked for another 15 years doing factory automation, doing pipeline control systems, but a lot of it was electrical network control systems. I was sent to Spain for a month and came back a year later. Because someone told me, don't worry, the system's ready, all you have to do is commission it. I put my kid in school for a year as soon as I arrived, because I knew I wasn't coming back for a while. My colleague that got sent to Turkey was there for 8 years, so I think I got off lucky on this. So I understand the different process of this, and for the last 20 years I've been with Atigo, which is now PTC, doing the model-based systems engineering in a wide variety. And the good news is what I'm seeing is we're suddenly coming back to we need to do systems engineering and manufacturing, we need to do systems engineering and well everything. One of the big projects I'm working on these days is in oil and gas. Anyone know how you do systems engineering in oil and gas? You throw a lot of money at it, and because oil costs up to $140 a barrel, who the hell cares? Get the gas out. You make your money back. Now that it's $40 a barrel, not so much. So they're saying systems engineering. So we're looking at this. How do you make things more efficient? How do you do prediction? Because this is the other thing they're looking at. So to answer the question, I'm a little more optimistic than Ed, but it's hard to be less optimistic than Ed's comment. But he is right. We're not yet in this. You talk to people. Again, I went to an oil and gas conference and they said, we've discovered this great thing. It's called requirements management. And we realized we need to do this, which, you know, is probably at least 30 years old, minimum. And I made the comment, you realize you've effectively made the statement equivalent of, we've just discovered fire from a systems engineering point of view. So I said, you guys need to move. Anyways, manufacturing needs to become more front and center, product lifecycle management, all these other aspects for systems engineering, because one of the biggest thing is we're all concentrating on the left side of the equation, we're not on the right side. That is to say, going through the entire life cycle and doing all this. I was having a conversation with Ariella and Paul Schreinermacher, and they said, why did the A380 fail? And the answer was you can't sell it to Africa because there's no way that you can actually send this to the secondary market. Therefore, everybody has all these airplanes they can't reuse. Who thought of that? Probably a good systems engineer would have. So, digitize the enterprise, go through the life cycle. Here at INCOSE, we need to stop being so much, well, if it's applied, therefore it's dirty. If we're trying to actually figure out how do you get on with these things, then it's considered, well, you're too far away, you're just trying to sell me something. Yes, a solution. And we're trying to move things along. So promote standards. I'm on the architecture board of the OMG. I was there last week. In fact, I traveled directly from there, which is to try to define standards that can be used through on. One of my best friends is Rick Dove, who's in charge of agile systems engineering. I'm trying to shift him over to the model-based side of things. I think if we have another 20 years of sessions at INCOSE with cigars and whiskey, I'll get there. But it might take me a while. And put MBE into course curricula in the universities. A lot of what I used to do when I lived in the UK for 20 years was to talk to universities, talk to schools and say, how do you actually move things forward? It's not being taught enough, and it needs to be taught agile, and as someone said this morning, universities need to be where people learn to learn. Certainly, listening to Ed, MIT is that place.
My name is Raz Eiferman. First of all, thank you for having me here on this distinguished panel. And I have to admit at the very beginning, I'm not a system engineer. So that's the issue. I'm coming from a close relative discipline, which is system analyst, and managing big or large IT divisions for many years. And in the last years, I serve as a consultant for digital transformation, and I'm a board member of one of the top 5 insurers in Israel, Menorah Miftachim. So my perspective of looking at the system engineering is from a manager and a board member perspective. I believe that we are living in very interesting time, very exciting, but also very, very challenging. So, and I believe that system engineers have a very complicated task. I would say in two different dimensions. One of all, the first one is managing the complexity of the new architectures, which, as we heard in the morning from the Army, and as we all know, systems are going to be more and more complex, more and more distributed, and more event-driven. Not database driven, event driven, and of course the data will be gathered and managed. The second dimension is hiding the complexity. It's not just managing the complexity, it's hiding the complexity. I could imagine that if Uber, for example, would develop an application in which most of us would be exposed to the complexity behind the processes needed to order a taxi, to report that I finished my ride and I have now to pay, and I want to score the driver. If all of these processes were not hidden well in just one touch or maybe one click, nobody would use it. So we have to work in these two different dimensions in parallel, managing the complexity and hiding the complexity. And I believe that the system engineering is one of the most challenging disciplines in the coming years, because, as I said, we will make more and more complex, distributed, edge computing, cloud computing, on-premise computing, with many, many protocols and many, many different devices on one side, but second, we have to make sure from a usability point that they are made simple, one touch, if possible, of course. So the task of the engineer is not just to manage the complexity, is to understand how he exposes the simplicity of the system behind the complexity that is beneath. So I'm sure that the discipline of system engineering and system analysis, which is a close relative dealing mainly with software, will have to evolve and to make sure that we are able to meet the challenges of the new, complicated, and very, very distributed architectures that we are moving it. So it's challenging times. Thank you.
I'm Ariella Sofer, or Ariella Sofer, if you like. I'm also a legal immigrant into systems engineering. My background is actually, can you hear me? My background is actually operations research. I got a master's from the Technion in operations research, got a PhD at GW, George Washington University, in operations research, and went to George Mason University, and initially I was teaching operations research. And the fact that I'm originally from the area of operations research clouds my perspective. Also, I'm an academic, so that clouds my perspective, or maybe not, but informs my perspective. And what is unique about operations research is that the most important thing from the beginning that you teach students is, first of all, how to build a mathematical model of your problem. Then you may solve it in a variety of ways. And often within the mathematical model, there is uncertainty or stochasticity and data that comes in. Then you solve the problem. And at the end, once you solve the problem, you ask what if questions. And this act of modeling is very, very important. It gives you, it's almost in some ways synonymous with systems thinking when you think about it, or at least a big part of it. Roll back a few years later, I assumed the chair in 2002. I became the chair of the Department of Systems Engineering and Operations Research. It's a department that combined systems engineering and operations research. And we had luminaries such as Andrew Sage and Alex Levis and others. And initially I thought I didn't have to know anything about systems engineering. But actually I later found out that actually the department needs leadership in the education. We have an undergraduate in systems engineering, masters in systems, masters in operations research. I established a PhD in systems engineering and operations research. And by default, I became that illegal immigrant where I actually migrated into systems engineering. One of the things that astounded me in 2002 that there were no models in systems engineering. The model-based systems engineering was only developing, and it was I think systems engineering was behind in some ways in establishing models. I think it still is behind in understanding uncertainty. I'm really glad how about the development of model-based systems engineering. Other areas, such as Victor mentioned, maintainability, reliability, they're all sort of parcel of that, but not actually part of parcel of systems, and so we should be a little more broader in our perspective. And so I'm glad. By the way, the models I'm speaking, the mathematical models, are very different than systems engineering model-based systems, but we should be able to have them speak to each other, and the more we can actually have different models speak to each other, the better we are. So.
We have four topics, four dilemmas. I don't know if they are dilemmas, but 4 topics. And any one of you is welcome to address them. This is like a follow-up to what you have presented. So we have a sketch of systems in the new era, and we have some context with traditional systems engineering processes. Where are the gaps? Anyone? No commercials.
No commercials. I can talk about my standards, though, right? Okay. Ariella mentioned that all these different models need to talk to one another. A couple of standards-based elements is The SysML2 group is looking at specifically this, that if you've just got SysML and it's an island, it's pretty useless. It needs to interoperate with the rest of the things. And one of the things I'm pushing through, again, standards such as OSLC, is not I take all this data, convert it over to here, convert it over to here, convert it over to here. It's how do you get these things talking to one another, interconnected. So if my requirement changes, it shows me in my logical design how it does it. So the interoperability aspects and throughout the entire life cycle, so that way if you suddenly have a spare parts problem, how can you work that back through to find out where you got the requirements wrong? So it's the interconnectivity, the ability to actually see what we call a digital thread. Lockheed Martin calls it a digital tapestry, but I think they just changed the term recently. Everybody has their term. And the DoD in the US has the Digital Engineering Working Group who's trying to do the same thing. How do you get these things? And I think I've almost convinced them it's not interchange and translation of data, it's interconnectivity that does it. That's my opinion.
So interoperability, when I was working for Tadiran, was a big issue because you develop a system and then it's going to be deployed in different contexts and okay. So you have the left to right, how do you design it? But then you also have the right to left, how do you evaluate it? How do you test it? Okay, so there are two aspects. There's the design engineering aspect and there's the testing engineering aspect. And both present interesting challenges. Yeah. Anyone else?
I would like to add a different perspective to the system. System engineering is engineering, and engineering is about technology and science and discipline. And sometimes, and I'm working on digital transformation, and the challenge that I find very often is the cultural part, not just the engineering part or how the systems are implemented or deployed into organizations. And there is a concept of digital maturity. And we have to understand and to measure. And there are different ways to measure maturity. But part of the system engineering discipline is to understand the capability, and I'm talking more about organizations, okay? The capability of organization to absorb and digest these all new digital systems and changing the way they work and changing the processes. And this is hard, believe me. Sometimes it seems that the most challenging part of a system is the technology part. I'm sorry. That's not the one. The most complicated part is the people part. How do we make the people use the new systems and make effective use of it? And how do we bring simplicity with all this complexity into the organization? Because the reason all of us are using the iPhone or whatever is because it's simple. Because with a touch, we can make a function. If you look at the organizational systems, there is no touch. Okay, there are a lot of screens, a lot of data, very complicated. People sometimes don't understand exactly why they are doing what they are doing. So please remember, as system engineers, to add the people factor to all the complexity that you're dealing with.
Okay, thank you.
I would like to echo what Ross said, and actually I forgot to mention that one of my other functions, I'm the academic director of INCOSE, and within INCOSE we had, within the academic council, we had a group of members doing what is the future of systems engineering research. And they looked at the various problems from the systems engineering vision or national grand challenges and what are the challenges for systems engineering? Where do we have to develop? And one of our major conclusions was that one of the things where we really have to develop knowledge is the understanding of the social, technical matters, how humans behave, and in many irrational ways sometimes, or devious ways, but we have to be able to understand that in order to understand systems engineering to develop. So I echo that.
Do you know what Cameo is? C-A-M-E-O. These are MOOC participants in MIT programs that register under 10 different names so that they can get the certificate after they've tested the system. You didn't know about that.
So let me start by taking a poll. How many people are familiar with the V model of systems engineering? Yeah. So I think one of the problems, I would claim that the V model is terribly inaccurate and obsolete. And yet we teach it too. Everybody learns the V model. And there's a couple of things wrong with it. It's reductionist. It takes systems, breaks them down into their components, then puts them back together again, tries to test them in between. It's very procedural oriented, it's not really. What systems engineering is not really engineering in the sense of electrical engineering, because we don't have an Ohm's law, or a Newton's law, or any of these mathematical relationships between our systems. They're just getting more and more complex and more hard to represent. Things are changing faster than we can change. And so part of the direction I'm going in is systems thinking and not systems engineering, because as several people have pointed out, there are a lot more factors in systems engineering these days than engineering factors. There's political factors, there are social factors, there are environmental factors. There's all these things that we have to take into consideration when we build a system and do so in an unscientific manner. We have to fix that.
Okay, so we move to system thinking. I think we discussed challenges, opportunities. Oh, okay.
So these are just several thoughts that have occurred during the morning. The first one is, where's the Bell Labs of system engineering? Right? One of the things that the Bell Labs did for several decades is they drove a sort of integrated, business-focused approach of taking technology as science and moving it to its products. Now, they weren't very successful at making money for the Bell company, but they did a lot of good work. You know, I'm an system engineering researcher, and I work on my little piece. And the next engineering researcher works on their little piece and so forth, even though we recognize it's a system. I was awestruck by this brigadier who spoke this morning. I think that's who he was, if I read his rank correctly, the general who spoke this morning. You know, I get the sense, here's a guy who really has to manage one of these complex systems. And if I put myself in his shoes, I wouldn't know what to do. I mean, it's almost, I mean, there were so many buzzwords on those view graphs that, you know, you'd have to spend a career just learning what they all meant. And yet he has to field a system that actually does all those things. It's secure, that takes in data and so forth. I'm getting someplace. One of the interesting things about Israel is it's a country of, what, 9 or 10 million people? Not yet. What is it, 6 or 7 million people? 8 million people? Okay, I'm a system engineer. Half an order of magnitude is close enough. You know, in the United States, it's a country of 300 plus million people. It's a scale of 30 larger. And you can never get a talk like that one, because there's no one who has enough of the view of the system that general had. So one more point and then I'll connect all the dots. When I go to teach system engineering, the biggest limitation I have is that it's sort of me and a few textbooks and my experience and my colleagues' experience and the students. Now, you know, the colleague that I teach the Advanced Space System Engineering course just stepped down as the Senior Vice President of Airbus. It's not like we don't have some experience amongst us, right? But still, it's just a few people. So here's an idea. Is it possible to make a sort of sample problem? Is it possible to make some sort of virtual simulation of how many of these problems that we're talking about and all the things that were on the general buzzword bingo charts fit together so that people in universities like us actually have some hope of teaching the students how to address the real industrial strength problems? And I just have an idea, an inkling of an idea, that Israel is a country of enough of the right scale so that you have both the problems and the competencies within it. This is something that could be created by Israel, INCOSE IL, and could be a service to the world community. I don't think you could do it in the United States. By the time you collected the people to discuss it, the room would be full of 50 or 100 people. But in Israel, I have a feeling you might be able to find 5 or 10 people who would know how to do this. So it's something the universities and the IDF in Israel could cooperate on. You guys know about this, so I'm giving you a challenge. You could do something that would be very helpful.
How do we call this? The MIT challenge? The ED challenge?
The ED challenge.
Okay.
Where ED stands for education.
Of course.
But if you figured it out, I could get it on edit. I control the portal to the digital world.
Okay.
So I try to echo and to maybe not meeting the challenge, but discussing your challenge, okay? I had a very a good experience in my company doing a project where I wanted to involve the people side, as mentioned here, the human side, from day one. And it was not the tradition there. The tradition was that the human factors will be introduced after we have the system. Laterly. Don't confuse me with the people in the first. So I brought to my project manager, as the system engineer of the system, the guy that is, it was a lady for that time, that will explain what is human factor engineering. And after this meeting, my project manager was I think he was convinced to do what I asking from day one. We will have human factor engineering as considered in our project. And what we have done through the whole project, it was a long one, about 10 years of developing and testing and deploying and so on. In each step, we have considered human factors as part of it by the experts themselves and us as system engineers and the engineers, the disciplinary engineers themselves. Based on this experience, we have created, as you ask us, INCOSE IL, a group that is talking about how to integrate system engineering with human factor engineering. And we have created a working group with system engineers and human factor engineers, some of them practicing, some of us academia, to work together, and to generate how to do it. Because for now, we know how to do it by book, but we don't know to do it in practice. And most of the people ignore this policy or this approach, okay? And Ami Arel that got today the award, he's heading, I asked him to head this group because he has the two sides, system engineering, also he had project with the human side inside it. What we came out in the only last months, after working how to integrate this one, we have got into a new direction. We have found that we have to design a new discipline. Do you hear us? We want to design a new discipline that we call it human system integration as a new discipline. Not as a discipline that trying to integrate system engineers with human factor engineering that don't want to integrate, but a new discipline that this human system integration is a discipline with a way of doing engineering and so on. I don't know if it will be successful or not, but the thinking about it brings us for new insights. That it's not enough only to integrate the disciplines, but to find new processes, new system thinking that really integrate the human side. And what we look at it, the autonomous cars. In the autonomous cars, I think what will happen is that the integration of human and systems and processes and ethics and so on will be a new discipline that has to be developed. So I think what we have to do in the system engineering in the fourth industrial revolution is to think out of the box that solutions that are linear is not good enough, as maybe as also suggested by Ed, that we as non-digital generation cannot think in the same way as a digital generation, and to give these people, because of that we have the session afternoon with the youngsters that are thinking not linearly, but thinking out of the box. And maybe as in the HSI, that we have a new, trying to create a new discipline, totally new discipline, based of course on the previous discipline, that maybe will bring us a better solution. Thank you.
Okay. So, okay? So I was going to move to the next slide. So here you are. You are on the right there. Yeah.
Okay. So I have a question. My name is David. They ask you if the system engineering is ready for the fourth industrial revolution, and basically all of you have said no, except for you. You said somewhat, but basically all of you have said no. And what I'm asking is that someone is bringing the first industrial revolution. It's happening. The Internet of Things, the autonomous cars, the fact that the 15-year-olds have all the information in their fingertips, someone has done it. So the systems are somehow engineered. So who is doing that? So how can you say that the system engineering is not ready for that when there are system engineers in Google, Facebook, other companies, or software engineers, someone that is doing all of this revolution?
You want to answer this?
That's why I said somewhat. So I'm going to pass it back because that's why I said somewhat.
Well, thank you for a very good question, an intriguing question. I don't know the answer exactly, but I can approximately give you my opinion, and that is that we can do better, and we're going to have to do better. So, yes, there's people designing these systems and doing a good job at it already, but it's moving. So I think this velocity of change is what's got me worried. Things are changing so quickly. The amount of data is increasing so quickly. Processing power, communications, it's all growing exponentially, and we can only wing it for a little while longer, and then it's going to get out of hand.
Yeah, the Bell Labs. So Bell Labs developed the telephone. They manufactured it. They installed it. They serviced it. Okay, so they had the grand picture, and so Schuhart developed the statistical process control chart because 45,000 people in Cicero, Illinois, in the Hawthorne plants were actually putting together telephones that were developed by another lab in Bell Labs, and these telephones were put in the field, and if there were problems, the whole system, the AT&T system, 1 million people had the AT&T. So there was this integrated view, and it created the motivation to have an integrated solution. And I think the thing has been, so the tapestry is that, who has the integrated solution? That's really an interesting question. Google, they have their own perception of what is optimal. The Siemens pushed the industry with the E 4.0 as a marketing trick to push for their systems and create demand. But eventually it caught on, so now it has a life of its own. But the vendors, I meet vendors, I meet Microsoft Azure and IBM Watson, etc. They don't have the integrated perspective. They push their systems, and the difficulty is that they make claims that their systems will be the answer. And so people it's very tempting. I'll write the check and here's the solution to my problem. But then the solution is not appearing. So that's why maybe system engineering as a discipline, as a research, can have some kind of role in providing this integrated perception. Yeah.
One of the things, as you heard, I sell software. I also do training, consulting, etc. And the thing that depresses me most is when people say, okay, I've got your SysML tool. Great, we don't need you anymore. I'm off. And I just think, oh, well, that's another project failure. Because one of the biggest problems is you don't learn systems engineering by looking at a tool. You learn systems engineering by doing it. The tool helps. But the tool is never the solution. The tool is a tool. I've got a saying which is that if you use the wrong end of a hammer to hammer in a nail, it's not a bad hammer, you're a bad carpenter. And what people need is to make sure that when you get all these tools, that you get proper training and proper consulting from people who've actually done this before. I keep hearing of people who've never done this before, and sometimes my company is guilty of it. Well, let's just get some people in there. And I just think, please don't. Please, please don't. Because there are enough, the 40,000 monkeys will eventually type the complete works of William Shakespeare, but it will take a long time. So let's get the training, and maybe some of these digital people can actually help us with that.
Talking about system engineering. Most of engineering is based on, I think somebody also mentioned it, formulas. We have Newton laws and then the rest. People who do, fluid dynamics, they have Navier-Stokes equations and the rest. And those who do radar and others, they have Maxwell equations. In system engineering, we don't have those. And maybe for engineers, it's something that they need the kind of a basis. Their language is mathematics. So is there something like that in system engineering? Maybe we can do it. I think Ariella mentioned. In fact, engineer is somebody who is doing optimization. Why not the language of optimization or operation research? I think in most of the system engineering papers that I am reading, very little, if any, mathematics.
There's a lot of mathematics that should go into that, including dynamical systems, and which I think every systems engineer has to understand. Well, not every, but a few of us, or a few have to understand how to model dynamic systems, operations research, optimization, stochastic systems. There are a lot, but that's, I think that in Israel, the masters in systems engineering are respectable in this respect. I think in the US, the masters have very little mathematics, and I think that's a downside of our training in systems engineering. Or most programs, not all, but most programs don't train people to think mathematics. I can't disagree with you, Is there mathematics hidden there that we don't know about? Someone better than me has to answer that.
Hi, my name is Yoram. I'm working at Rafael Company. I'm a system engineer there, and I was a system engineer. Now I'm working in the systems design. And I would like to ask something that I didn't hear today. We talked earlier about data. That is something very important. And I think also the process is very important. But as a system engineer, I would like to ask the following question. What about taking the psychology and put it inside the system engineers? Because we all people, and everyone has an enemy inside, the ego. What we are doing with the ego when we all sit and design systems, and even system of systems. And I think that we need to focus on the psychology and about how we communicate each another. I'm working in the communication division, and the communication is something very simple. We have two rules. The first of it is that we need to talk the same language, but the other is to listen. And to listen, that not something that most of us, or I hope most of us, know to do it. But those two rules, if they are not in the system engineering, in the designing, we have a lot of problem here. I would like to hear some of you talking about those aspects.
So I knew about egoless programming. Is there egoless system engineering?
Engineers are mostly introverted, as everyone knows. There's an old joke, is how can you tell an extroverted engineer? And that's when you introduce the engineer to somebody, he looks at your shoes. Doesn't translate well. Okay. Anyway, engineers are traditionally introverted, but systems engineers should not be. So the point of studying psychology, the point of studying, things that are beyond the engineering realm, I agree with you, very, very important, and it should be an important part of teaching systems engineering and developing systems engineering, leadership skills. Same thing, systems engineers need to be leaders on the projects that they work on. And the typical engineer is not good at that. And so that's part of what has to change.
One of the biggest things is the assumption that you should always start with is that you're probably wrong, and you're going to continue to be wrong about something throughout the entire development, and always be looking for that wrong thing, listen to others, etc. The biggest problem that we have is overconfidence in our abilities and lack of confidence in other people's abilities. So one of the things I teach my students when I do this is to work together in teams, and because generally you'll do an exercise and everybody will sit and stare at each other because nobody wants to put something down on the paper because it might be wrong. And my statement is, don't worry, whatever you put down will be wrong. There will be mistakes, but until you put it down, you don't know what those are. And this gets rid of a lot of ego, it gets rid of a lot of arrogance, and it helps people to work together.
Yeah, a book that I think is a must-read that has an Israeli aspect and could be used in system engineering is The Undoing Project, Michael Lewis, The Undoing Project. It's on Kahneman and Tversky's evolution into behavioral economics, and they talk about all these biases, and it's a fantastic book, and it really talks about the Israeli Air Force, so you can also relate to the Israeli experience in that book.
Raz started an issue of involving the human and the engineering. Now I want to take it to a disruptive point of view. If you were listening, most of the people around here spoke about one problem. How do people go into engineering? So the disruptive point of view is not speaking about system engineering, but speaking about system concept when the engineering is out and the concept is in, because you have to deal with human. You have to deal with people, you have to deal with teams. So the matter of the system involves educating people to work together. If we're going to what the description was of the general before, or what's happening around here, is that people, one way or the other, are learning to work together. And maybe this gives you an uprise about other places where people are going into engineering, but not about teamwork. So what I want to ask you, if it's not about time to change the definition of system engineering to system concept, when humans and people and teams are part like any other issue inside. The same as once upon a time there was electronics and mechanics and optics, and then they said they all work together, they cannot be separated. Put people in the loop and maybe it will be much better.
For many years, again, my apologies for doing an advertisement for PTC, but the point of the whole thing was you need the big picture. So this won't be another advertisement, so I really normally don't do that. Anyways, I'm also, in addition to working on the System L2, I'm a co-chair of what's called the UAF group, which is looking at architecture frameworks. And for 10 years, I pushed to have human factors integrated into this framework. You probably know DODEF here, most people do. And the initial systems for DODEF, you were unable to show how people and systems work together. You had the people view and the system views, you couldn't combine them. Luckily, DODEF 2 fixed that, but what they didn't add were, bizarrely, security views. DODEF doesn't have a security view, honest to God. Anyways, but also human factors, and starting with human factors. Because if you look at how they do it, and Avi knows this, you've got your human factors models, you've got your systems models, and for God's sakes, never have those two work together. And so what we've been pushing, and the reason we integrate it, is to get the human factors in there integrated so that you're not doing the same thing twice and then pushing them together. Like if you put two books together, you don't merge the knowledge, because this is the problem. And again, it's about this interoperability and thinking about the people first, because it's always people, process, and then tools.
Hello, my name is Leah Goldin, and I would like to challenge you. I think that we are far beyond system engineering. We are now in the era of enterprise system integration. So the challenge is nowadays integration. And instead of using the word integration as an adverb, as an adjective to say integrated system, that's wrong. I mean, we are now in the era of enterprise system integration, including software, hardware, knowledge, human performance. Why talk about human factors? This is an old concept. We are talking about human performance. So I think that all that have been said here, if we just take it into the new notion of enterprise and try to understand first and then learn how to implement the term interoperability. I mean, this is what we are now challenging in systems themselves and between the system engineers. So if you can respond to that, I will appreciate.
I want to thank the participants in this panel, the audience, and the fact that everybody stayed.